Welcome to my viewers to that channel. So here we'll discuss again universal set. In the context of a particular study, the set containing all the elements of the subject of study is called universal set. And universal set is denoted by capital U. The symbol is U. Now it says in the context of a particular study. Now let's talk about the number system. That means our context of study is the number system. Now in the number system, the real numbers contain all the numbers like rational and irrational. Rational numbers means we denote this by Q. Q naught means irrational numbers. So if we represent this box containing real numbers, that means real number is the universal set here. Now we can subdivide the real numbers into two groups, Q and Q naught. Q means rational numbers, Q naught means irrational numbers. Now within rational numbers you find integers and fractions. So this parabolic set, this represents the integers. So within rational numbers you find integers. Integers are within rational numbers because every integer is a rational number that we have discussed earlier. -2 equal to -2 by 1, right? 0 equal to 0 by 5, etc. So every integer is a rational number, can be expressed in p by q form, where p and q are integers, q not equal to 0. So every integer is a rational number. So integers, the set of integers will be within rational numbers. Now there are some rational numbers which are not integers. So let's denote these numbers here, these dots. They represent some numbers which are not integers. That means they are fractions. Now every whole number is a integer. Every whole number is an integer, like 0, 1, 2, 3, 4, 5, etc. These are whole numbers. Every whole number is an integer. So the set of whole numbers lies within the set of integers. Now every natural number, 1, 2, 3, 4, 5. Natural numbers are denoted by n. So every natural number is a whole number. So the set of natural number lies within whole numbers. Now representing the sets in this way, in this diagram, is called Venn diagram. This concept was developed by John Venn, a British mathematician. So it is known as Venn diagram. We will discuss some more examples of Venn diagram. Now here the context of study is universal set, and this context of study here, the subject is number system. So here R is the set of real numbers, is the universal set. Now take another example. Suppose we are studying about the students of your school. Suppose the set of all students of your school. Now the set of all students of your school, we treat this as universal set. So we use this as U equal to S, all students of your school. Universal set here is S, all students of your school. Now you can define too many subsets under this set. Say this is say students of class 10, suppose, this set. Then students of class 9, suppose. Students of class 8, suppose. Students of class 5, suppose. etc. The students of girls, students of boys, etc. Right? So you can define subsets like, say, T equal to the set of students of class 10, and equal to the set of students of class 9, etc. Now in this context, the set containing all the students of your school is the universal set, right? So in the context of a particular study, the set containing all the elements of that subject under study is called universal set, right? Next concept we will discuss here is interval. Interval. Now we have discussed a real number system earlier. All real numbers can be represented on the number line, right? Now suppose A and B are real numbers. Real numbers. Now this is called open interval. Open interval, and this represent this actually represent the set of numbers x such that x is greater than a but less than b, and x is real number. This is called open interval. Open interval is written within parentheses like a set of ordered pair, like here a comma b, this ordered pair is called open interval. Now this represents the set of real numbers which lies in between a and b. That means not this will not include a and b. This will include numbers in between a and b. X is greater than a but less than b. Suppose you write this interval minus 4 comma 4. So this will represent x such that x is less than 4, x is greater than minus 4, and x is, say, integer, suppose. Now if you write this in tabular form or roster form, what are the elements here? The integers in between 4 and minus 4. So you will find minus 3, minus 2, minus 1, 0, 1, 2, and 3, right? Now this is called A, B. This is called closed interval. Closed interval. So what is defined by A and A comma B here? This is a set such that x less than equal than b, x is greater than equal than a, and x is a real number, say real number, right? So this interval is called closed interval. It includes a and b and all the real numbers in between a and b, right? X is less than equal than b, that means this set will contain b also. X is greater than and equal than a, that means x will contain a and all those numbers greater than a, and number b and all those numbers less than b. So x will contain the numbers in between a and b, including a and b. So it's closed interval. Now what will this set contain? This will contain x such that x is greater than a but less than equal than b. X is real, right? Here one side open, that means x is greater than a, and this side closed, x is less than equal than b. Similarly, this, suppose this time closed in the left side, open in the right side. So this will represent x such that x is greater than equal than a and x is less than b. X belongs to R, set of real numbers. Right. This is how we use define intervals. We will use this concept of interval in function relations and function, and in defining some sets also. So let us talk about some examples here. Write down all the subsets of the following sets. All the subsets of the following sets. Write down all these subsets. Now question number 1. So what are the subsets of this? We know that every set is a subset of itself. So subsets of this are this and one is this. That means 5. That is, one is this, another is 5. 5 is subset of any set. Every set is a subset of itself. So this set itself is a subset of this. Right? Similarly, question number 2, AB. So what are the subsets of this set? First, you write sets containing one element. Second, AB. And last is 5. So these are the subsets of this set. Now, question 4, suppose 5. Subsets of this set is, every set is a subset of itself. So it's 5. 5 itself is a subset of 5. Write the following as intervals. Following as intervals. So question number 1, it says x such that x is a real number minus 4 less than x, x less than equal than 6. So how will you write in terms of interval? Here x is greater than 4, so you will write here open interval minus 4. And x is less than equal than 6, so this time you should include 6 and those numbers less than 6. So this is closed interval, right? Similarly, question number 2, x such that x belongs to R minus 12 less than x, x less than minus 10. So in terms of interval, you write, you didn't find less than equal than symbol here, so this will be an open interval. X is greater than minus 12 and x is less than minus 10. X is less than minus 10. So what are the numbers in this interval? The real numbers in between minus 12 and minus 10. Similarly, question number 3, it says x belongs to R. X is a real number. X is greater than equal than 0. X is less than 7. So if you write in terms of interval, you will get left side it is closed interval 0 and right side it is less than 7. So it is not including 7, so it will be like open interval on the right side. So left closed, right open interval. This is known as left closed, right open. This is known as open interval. This is left open, right closed. Question number 4. X such that x is a real number. X lies in between 3 and 4, including 3 and 4. So when it is including 3 and 4, so it is a closed interval, 3, 4 closed interval, right? Now this question is just opposite to this. Write the following intervals in set builder form. Set builder form. So question number 1, -3, 0. It's an open interval. So we'll write in terms of set builder form. X such that x is a real number. Now what is the property of x? X is less than 0 and x is greater than -3. X lies in between -3 and 0. Question number 2, 6, 12. It's a closed interval, close in both sides, left and right. So it will write x such that x is a real number and x is less than or equal than 12, x is greater than or equal than 6. Number 3, it is left open, right closed. So you will write x such that x is a real number, x is less than or equal than 12, it is greater than 6, right? Number 4, it is left closed, right open. So define this x such that x is a real number, x is greater than or equal than -23, x is less than 5, right? Now let us discuss this question. What universal sets would you propose for each of the following? The set of right triangles, the set of isosceles triangle. The set of right triangles. Right triangle means one angle is 90 degree, right? So set of right triangles means this type of triangle where one angle is 90 degree, but sides, sometimes base is shorter than perpendicular. Sometimes this is base and perpendicular are equal. The set of isosceles triangle means triangle whose two sides are equal. Sometimes right triangles also, you can find it, these sides are equal, 45 degree, 45 degree. This is 90 degree. Now, what universal sets would you propose for each of the following? The set of right triangles and the set of isosceles triangles. Now you see that every isosceles triangle may not be a right triangle. Every right triangle may not be an isosceles triangle. So here we will define universal set, the set of triangles. Set of triangles. Now under this you can define, say, right triangles may be defined as the set of right triangles and isosceles triangles, say I, the set of isosceles triangle. So here universal set is the set of triangles. Within the set of triangles you will find the set of right triangles and the set of isosceles triangles. So The proposed universal set is the set of triangles. Next thing here we will discuss here is complementary set. Complementary set. So, say for example, A equal to, there are 4 elements 1, 2, 3, 4. B equal to 1, 2, 3, suppose. And here we will define a universal set. Universal set is 1, 2, 3, 4, 5, 6, suppose 7, 8, 9, 10. That means first 10 natural numbers. Now the complement of A, it is defined as A complement equal to these elements which are within the universal set but not within A. So what are the elements which are not in A but these are in U? You will find that 5, 6, 7, 8, 9 and 10. Similarly, B complement equal to the set of elements which are within U but not in B. That means you will find 4, 5, 6, 7, 8, 9 and 10. So you can define it as A complement equal to X such that X belongs to U, X not belongs to A. Similarly, B complement equal to X such that X belongs to U, X not belongs to B. Right? Now you see cardinal number of U. How many elements are there? 10 elements. Cardinal numbers of A is 4 elements. So cardinal number of A complement equal to, you see how many elements are there? 1, 2, 3, 4, 5, 6. 6. That is 10 minus 4. So A complement, cardinal number of A complement is cardinal number of U minus cardinal number of A. Similarly, cardinal number of B complement equal to number of elements in U 10 minus number of elements in B 3, that is 7. So you see B complement, how many elements are there? 1, 2, 3, 4, 5, 6, 7. 7 elements, right? So okay viewers, thank you for watching this video. We will discuss on this in the next class again.